Welcome to Two Projects. In this video, we are going to see significant permission identification for Android malware detection. Introduction. Despite having 82.8% of the global market for smart mobile devices, Android is under 97% threat from cyber criminals. In 2015, there were only 2.33 million malicious apps found. In order to find malware, researchers use static and dynamic analysis. But these techniques sometimes result in false positives. Based on permission usage, malware for Android is being detected using machine learning and data mining techniques. Objective of the project. The project introduces a notion known as significant permission identification in an effort to increase the accuracy and shorten the execution time for detecting malware in Android applications. The project prunes common and less important permissions from the original 135 feature list using multi-level data pruning, including permission ranking with negative rate (PRNR), permission mining with association rules (PMAR), and support-based permission ranking (FPR). To achieve more effective and accurate Android malware detection, the implementation uses decision tree algorithm and compares the performance of the pruned feature sets to the full permissions feature set. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDEL of Python 3.7 version. Techniques used. In this project, the main machine learning algorithm used for Android malware detection is decision tree algorithm. Decision tree is a supervised learning algorithm used for classification tasks. It creates a tree-like model by recursively partitioning the data into subsets based on the feature values. Each internal node represents a decision based on a specific feature, and each leaf node represents a class label. In addition to decision tree, the project also introduces three major pruning techniques under the concept of significant permission identification. The first technique is permission ranking with negative rate (PARNR). This technique prunes out common permission subsets required by both malware and benign applications, reducing the permission list for analysis. The second technique is permission mining with association rules (PMAR). PMAR finds association rules between permissions obtained from the PRNR step. It identifies common and frequent permission pairs between malware and benign apps, which are then pruned from the permission list. The third technique is support-based permission ranking (FPR). FPR further scans the association rules from PMAR and retains only those permission features with higher confidence values while pruning out permissions with lower confidence values. To execute this project, we have designed the following modules. The first module is Upload Android Permissions Dataset. This module involves loading the Android malware dataset containing more than 200 permissions in a CSV file format for further analysis. The second module is Run Decision Tree on Original Dataset Features. In this module, the decision tree algorithm is applied to the full set of permissions to establish a baseline performance for Android malware detection. The third module is Run Decision Tree as Permission Ranking with Negative Rate. In this module, the PRNR technique is executed to prune common permissions required by both malware and benign apps, reducing the feature set. The next module is Run Decision Tree as Permission Mining with association rules and support. Here, the PMAR and FPR techniques are applied to identify and retain only the most significant permission pairs, further reducing the feature set. In the next modules, I have Accuracy Graph, Precision Graph, Recall Graph, and F-Measure Graph. In these modules, a graph is generated to compare the accuracy score, precision score, recall score, and F-Measure score of each technique. The last module is Execution Time Graph. In this module, a graph is generated to compare the execution time of each technique, assessing their efficiency for Android malware detection. Execution of the project. To execute this project, first we need to open the code folder. This is the dataset folder in which I have Android dataset. These are Python main code files and this is the run.bat file. Instead of executing the project in command line interface, we have created this Windows batch file. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Upload Android Permissions Dataset button. A dialog box opens. Select the dataset and click on Open. It confirms that the dataset is loaded. Now click on Run Decision Tree on Original Dataset Features button to apply Decision Tree classifier on full original dataset permissions. So after applying Decision Tree on full permission, we got accuracy, precision, recall, F measure and execution time values. Now click on Run Decision Tree as permission ranking with negative rate button to apply PRNR technique and to prune permissions. So we can see dataset contains total 215 permissions, and after applying PRNR we got 159 permissions and we got more accuracy when compared to the previous model. Now click on Run Decision Tree as permission mining rules, mining with association rules and support button to prune permission with association rules and FPR. So we can see after applying this model, the permissions are reduced to 90. And we can see the performance metrics of this algorithm. Now click on Accuracy Graph button. So in this graph, on x-axis I have algorithm names and on y-axis I have accuracy. And we can see the combination of PMAR and FPR is doing well. Close this graph. Now click on Precision Graph button. So we can see again PMAR and FPR precision is doing well. Close this. Now click on Recall Graph button. So we can see the proposed model is doing well. Now click on F Measure Graph button. So in this graph, on x-axis I have algorithm names and on y-axis I have the F measure, and we can see PMAR and FPR is doing well. Now click on Execution Time Graph button. So here we are visualizing the time taken by each technique for executing the model and giving the results. The conclusion here is the project describes a novel method called significant permission identification that uses multi-level data pruning to identify Android malware. In comparison to conventional methods that use all 135 permissions, the project improved prediction accuracy and significantly decreased execution time by applying PRNR, PMAR and FPR techniques to reduce the permission list. The PMAR and FPR combination outperformed other techniques in accuracy when the decision tree algorithm was used, making it a promising strategy for quick and accurate Android malware detection.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.